All right, so tonight we're going to be talking about C++, which it's basically C, but then there's a bunch of stuff that make it way better than C. So you learn it like very loosely in like data structures like CSG 300, but you don't really learn a lot about it. So we're going to talk about some useful things that make using C++ like why it's better than C. So like I said, C++ it includes all of the functionality of C. You could copy and paste a C program into a C++ program and it would work, I'm pretty sure. Only because I think I read that there's like one thing that might not work in C++, but it works. But the big things it adds object-oriented. So you can add like classes like you would use in C#. So you can add that into C++ and you can use classes with properties and methods in there. And then it includes some other features that make actually writing your program a bit less work, if that makes sense. So you don't have to like type as long of sentences, not sentences, but like phrases, or the logic can get a wee bit simpler because there's like a different phrase or something like that. So a couple of important differences between C and C++. There are many more than this, but these are ones I'm just highlighting. Input and output, instead of using like functions, printf and scanf, it uses these things called streams. So there's cin and cout, which is like scanf and printf, but then there's also file streams. There's string streams to manipulate strings kind of awkwardly, not awkwardly, but like differently. And then another thing is you use namespaces in STD, or not in STD, in C++. And namespaces, it's like a big group of functions, kind of. So you have to specify where each of your functions come from. So when you learn about C++ in class, you pretty much learn you stick using namespace std at the top of your file, and then you just move on from there. So what this actually is it includes the namespace std, which would be like standard, I'm assuming, as like a global namespace, so that when you use a function in the std namespace, you don't have to reference it explicitly. It just, if it doesn't see a namespace, it checks the std namespace to see if it's in there. So this is just fine for like a smaller program, like one file. All of our assignments, it works great for, because just typing std a lot is super annoying. But on big projects or where there's multiple namespaces involved, it's really considered best practice to not use it, just so that the code is a bit clearer where things are coming from, and it just makes it a bit better. So just a note on that. Question.
Is there an advantage or disadvantage of using printf versus cout in C++?
Cout is easier to use because, like in C, in printf, if you wanted to print like a number and then some text and then like a different number and then a different type, you do like %d and then your strings and then %f, I think, is float, and then like that. In cout, you just do cout, you do like say the string, and then you just put the number variable in there, and it automatically will make it a string and print it out how you want. So it can make printing more complicated messages a bit easier. That's the thing I can think of off the top of my head. I'm sure there's also performance benefits or something like that. So this example I have right here is a C program that just takes, it reads in a number, and then the number of numbers, or like if it's 4, then it reads in 4 more numbers. It adds those numbers together and prints that number. So this is what it looks like. It's a pretty standard thing. I'm not going to really explain it. And then this is that same thing in C++. So notice how it's basically the same thing. In fact, the only thing that's different in this program is instead of scanf and printf, it's cin and cout. So at the top there, in C, we use standard io.h. In C++, it's io stream, so input-output stream. It's just a difference. Notice you don't need the .h. You don't need those for the standard C header thingies. Here's that using namespace std thing that I just talked about, where you use it in assignments, don't really use it in other things. And then here is cin and cout. So the arrows can get kind of confusing. I like to think of it where C in and C out is like the screen. So it goes from screen to my variable, so that's when I'm reading it, and then it goes from variable to my screen, which is printing. That's just kind of how I kept track of it. And also, there's no std in front of those cins. This is the only example where I'm doing that. And the rest of it, there will be std namespaces there. So just a note, you'll see that later. So now into the stuff that makes C++ like actually really useful. So it includes some built-in data structures. So in C, we like have arrays, and then that's technically it other than normal variables for like the built-in stuff. Like you can make linked lists and stuff, but you have to do that yourself. It includes easier ways to work with strings. Like you don't have to use the weird like string compare function and stuff like that. I mean, you still can because, again, you can just include a C header file and do everything in that if you want to. There are some algorithms that you can just include, and it will do stuff like searching or sorting for you. And then there's a couple new keywords if you use like super modern C++, not super, but that can make iterating over stuff, for example, better. So the first thing I'm going to mention, just because it's useful later, is iterators. They're basically fancy pointers, kind of. They're type specific to like a vector is coming up. So a vector the vector iterator is different than say an array iterator. And these are just used so that it points to a specific location inside of that collection. So the first thing, and probably one of the most useful things, is vectors. Because vectors, conceptually at least, are dynamically sized arrays, which you can do in C, but it requires like manipulating the memory, and that's kind of annoying. So instead, you can just use a vector. You can still access it like an array, so name of a vector, square brackets, the index it's at, it'll work. But then vectors also include some methods to work with, so like to add things or remove things or find things. So it works best like in examples where like it's like it gives you a number and then you need to read in that many numbers of things. You can just make a vector, and then for each one you just add it to the vector. So here is a rough example of how a vector works. So all you need to do is you include the vector header file there up at the top. So then notice there I have std vector. That's just how you work with namespaces. So if you don't do using namespace std, you do that. You just do std : and then the thing. So what the vector int, I forgot to add line number highlighting thingies. So on line 5 there, where there's that int in the less than greater than signs, angle brackets, that's there. That is telling the compiler what type will be in the vector. Right now, it's just an int because that's a pretty simple type, but you could make it a vector of strings, vector of floats, vector of doubles, a vector of vectors. You could do whatever you want. So, and then notice I'm calling it list there. I think that might actually be a keyword in C++ if it's highlighting it, but so don't call it list if it doesn't let you. But then I'm declaring it just like you do an array. So I declared it 1, 2, 3, 4, 5. So then next there, line 6, list.pushback. That's adding 6 to the end of the array. So now the vector. So now the vector would be 1, 2, 3, 4, 5, 6. Can't do that with arrays really, without doing a lot of annoying stuff. And then the next line, int num, erase. Does that do what it does? We're going to go with it. Erase, it returns an iterator actually to the next element. When I was writing this, I forgot to change that. That's supposed to say something else, but that's fine. So it's erasing the thing at the front. It shouldn't be an int num at the beginning there. It's just erasing the thing at the front. But then when I print out num, now it prints 1. We're going to ignore that. I'm thinking of popping. It does that. So pop back. It would pop off 6, but it returns 6, and then you can print 6. But I accidentally did erase, so my bad. So the next thing that's also very useful in C++ is maps. Maps are kind of like vectors, but they store a key and a pair. So a key would be like the way you can reference it, so that instead of needing to use indexes for your array, you could do like a key of name, and then the value of name would be like the guy's name or something like that. There are two types of map in C++. There's the ordered map, which is like the default when you just import or include map. It's an ordered map. And this, it orders it when you insert a new thingy. It just sorts it by the key. So if you insert a bunch of like with keys like integers, it would sort it in integer ascending order by the keys. An unordered map just sorts it in like the hash value of the key, which makes accessing it much faster because it just can go there. So on that note, the first type must be a hashable type, which is like numbers and strings, simpler types like that. So here is another example. So including map, that would be our ordered map, and then unordered map is the unordered map, hence its name. So I have two maps there. Forgot to change that one to a string, but they should both be string comma int, which is saying that the key will be a string and the value is going to be an int. You can obviously make those whatever you want. So you could have ints and ints or int and then string, and that makes it so you can be flexible because that's super useful. So right now, inserting a bunch of pairs. Think of a pair like an ordered pair in like math class. So like 1, 3 is like an x value and a y value. That's what a pair is in this context. It's just a value, comma, another value. So when you're working with maps, the first one will be the key, second one will be the value. So the first one, it inserts them 1, 2, and 3. If I were to insert them 3, 1, 2, like I do on the bottom, and when I want the first one, it would still print 1 because it sorts them. So then the bottom one, it doesn't do that. So if I scroll down there, that's where the rest of the code is. So accessing it at MA, M is that ordered map, it prints out 1 because that's what is there. And then if I so m.begin gets the iterator to the beginning. That's how you would like loop over a thing or a vector or a map. And maps are weird. You have to use, it's like you're dereferencing it and then accessing the property. Those are the words. So first is the key, second is the value of the pair. So that's how that works. So the second there is getting the value, so 1 and 3. And notice how they're both at the beginning, but since in the unordered one, I inserted 3 first, but it doesn't like sort it automatically, even though this is a bad example because I changed the values and not the keys. Pretend like it's good enough. So that's the biggest difference though. Unordered, you just stick it in there if sorting doesn't matter. Sorting matters, use your regular map. So a for each loop. What? Oh, you're raising your hand.
What's the actual use case for maps versus other things?
Maps, I know they're useful. I just have to remember how they're useful because I've used them a lot.
Can I say it then?
Yeah, you got it.
Okay. So maps are basically for when you need to, you know how you use for arrays, you can use
2 arrays.
The index of the array in some fancy ways to get like you always access the value of an array by its index, but with maps you can do the same thing but with various data types and also numbers that aren't in order necessarily. So like you can keep track of a certain number for a certain string, and then when you want to access it, you can just go the map at this string to get the value for that string.
It can also be used if you have, like when you have, like when you have 2 arrays that store very similar data. So like the array, both of them at the same index share very similar data that you need to relate to each other. You can stick those in a map, and then you have the first and the second one right there. So you don't have to have 2 entirely separate arrays to store related data. You can just stick it all in one variable, and then it's easier to work with that way. That's another thing I did just think of. So a for each loop is basically a fancy for loop. It allows you to go over, say, an array without needing to do it based off of the index. So you don't have to do int I equals 0, less than the length of the array. It makes an easier syntax for probably a very common use of a for loop is looping over an array. So this just makes it much easier to work with. But note, it requires using C++11. So you just would compile it like that, G++, and then you just add that std flag, and you specify which version that you want to compile with. The most recent one, 19 or 20, maybe 21. 17 is the highest I ever go up to. But so this is, I think, the only feature. No, there's other features in here I'm including that need that. But so sometimes to get super cool features, you need to use that because it's just the newer version, because it defaults to like 98 or 99, whatever the first one was.
I have a question. So every new instance of C++ contains the same functions as the previous version?
Yep. So if you wanted to use something in C++ 17 and 11, you don't need to do both. You just pick the newest one, and it'll go all the way back.
Okay.
So the for loop, or the for each loop, here is just a for loop, but I'm calling it's basically read as for item in list. That auto there is another C++ 11 feature. It allows the compiler to like infer the type, which is good because the actual type of item right there is an std vector int iterator, which is many letters to type, and programmers are lazy, much like mathematicians. So you just use auto, and then it's short and easy. It works best when types get long, so that you don't have to type it all, and when the compiler can figure it out for you. So now if I print out item, it will print out 1, and then 2, and then 3, and so on and so forth from that vector. It just loops through it and does whatever you put in that for block. So lambdas, if you remember when we did JavaScript, we had callback functions. That's basically what a lambda is. It's just the C++ version of that. So it's not a named function. You pass it as a variable. Like I said, similar to callback functions. This is easier to show. So here, I'm declaring it as a function. So there's two ints there. There's int and then parentheses int. The first one is the return value of that function. And then in the parentheses would be like the list of parameters. So if I had an int and a string, it'd be int comma string, just so the compiler knows what's going on. Square is the name of my lambda. And then we get into the declaration of it. The square brackets is the capturing array. This is used so if you have variables above it, you can capture them into that function, and basically you just add them to your scope so that you can reference them if you don't want to, if they're not like a parameter value that you need to send, but you still need access to it. And then x is just the normal parameter. It returns an int, then you put it in brackets. It's returning x times x, which is squared. And then I can call it like a normal function. But then later on, I'll show you you can use it elsewhere too. Like in some of the fancy searching function. By default, it sorts ascended, and then you add it, yes.
So with the brackets, is that like anytime you want to use a variable that was declared outside of that function, you need to include it in the brackets?
Yep, so if there was like an integer x above where I'm declaring this function, I could put x in there, and then I can reference x safely inside of that function, and it won't get mad at you. If I tried to reference x without it in those brackets, it'd get angry because it's not in that scope. If that makes sense. All right, so now these next things, especially sorting and searching, they're very, very useful if you need to sort something and you don't want to write your own. But I feel the need to emphasize, if you get a homework assignment that is sort this array, don't just include algorithm and sort the array with this, because then you don't learn how to write a sorting function, and then your professor will probably get mad at you. Depending on the assignment too, if you have to like get sorted data, but that isn't the focus of the assignment, your professor would probably be fine with you sorting it, but you'd want to double check with them. But so sorting, usually you use it on vectors because it's like a simple type. You can't really use it on maps because they're more complicated. But you can use it on arrays if you want. So by default, it sorts it in ascending order. So if it's a bunch of integers, it'll sort it that way. If it's strings, it sorts it in alphabetical order. But you can change its behavior with a lambda. So you can pass in, its function, so it'd be sort, parentheses, the vector you want to sort, and then you can do a comma, and you can just define a lambda right there. And then you return true or false. True, it needs to move. False, it doesn't. Something like that. All of this we have linked, the like C++ reference website. It goes into the nitty-gritty of parameters and return values and stuff like that if you want to use any of these things. It's actually a pretty good documentation website. Some are bad, but that one's good. Another one is find, which is just searching. So it searches your collection for whatever you want. You put it in there. So if it finds it in there, it just returns the iterator to that element. If it's not found, it returns the iterator that is the end of the collection. And the end isn't the last element. It's like after the last element. And the reason this is just because it goes through. So if it finds it, it returns your iterator, but otherwise it gets all the way to the end and it wasn't there. It has to return an iterator, so it just returns that one. So then you can check, like, if it equals end, then that means it's not there. Another pretty useful one is any, all, and none of. There are 3 different functions that perform like the same thing, just with a couple differences, hence the any, all, none. What they can be used to do is you give it say a vector, and then you check if at least one of the things in that vector says greater than 18. So you got a bunch of ages, and you need to figure out who can vote. So you can see if any of them are greater than 18, and it will return true or false. If all of them are greater than 18, returns true or false, or if none of them are greater than 18, again, returns true or false. So this can be used instead of needing to do a for loop and go through each one and like set a variable and then check if each one is greater than 18 and then set false if it is. You can just do all of vector, set your condition, and then it can just do it for you. And then this for each is different than the other for each because they have 2 for some reason. This one is, again, it's used to iterate over elements in a collection. Key difference, this is a function. The other one is a keyworded for loop. A big difference here too is you can specify the range. You pass it a starting iterator and an ending iterator. So if you want to go through the whole thing, you just do like list.begin and list.end, which would be the beginning and the end. And then you pass it a lambda. And then that lambda, it runs on each item in the thing. It runs that lambda on it, if that makes sense. This is, again, a lot like .for each in JavaScript, like the same concept there. And then the last thing, which is significantly better than what we have in C, is strings. Because you can actually use strings like a normal person would want to, and like a language like JavaScript or Python, you can use them a bit better. It has fancier methods. You can add to the end of strings easier. You can add to the front of strings easier. You can compare them with a simple equals equals instead of the string compare function. So it's good to use them. In order to use strings, you include the string header at the top there. And then notice, unlike an int or a float, I have to add this std thing in front of string. And that's because string isn't a native defined type. It's defined in the string header and in the std namespace, but it isn't like a built-in one like int is. So you have to clarify that that's coming from the std namespace, because in C++ you can define your own types. So that's what string is. It's a type that a bunch of smart computer people defined in 1998 or whenever it was made. So this first string is hello world, and then the second one is also hello world. They're the same. I set them equal to each other. So notice I just did a plus equals exclamation point. There we go. I just added an exclamation point to the end of it. It's not that easy in C, if I'm remembering right. I'm pretty sure it involves one, probably more than that, functions. And then there I'm checking if s is equal to x. In C, you have to do that string compare function, which is annoying because it just doesn't look good. It can be moderately confusing. And since I added that exclamation point to hello world s, this if it won't enter that because they're different, because there's an exclamation point. But so this is much simpler than what you would have to do in C to get this to work. So that's just a brief intro delving into the big benefits of C++ stuff I don't think are like ever talked about in classes, but can be really useful. Vectors especially is probably the most useful thing I talked about tonight. I use vectors. Even if it's just going to be an array, sometimes I use vectors because they're easier to work with sometimes. So any questions?
What's the difference between std : cout and just cout?
So I might have forgotten to add a couple std : but std : is when you don't use using namespace std. If you use that, you don't need to include that, because then it knows that if you didn't specify that cout namespace, it can go look for it in there. But since on all of these other examples, I didn't put using namespace std up there, so you need to add std so that it knows where to look for it, because it's not a defined function in C. So hopefully that makes sense. All right, so Nick, you decide what we're talking about next week?
Putting me on the spot. We'll throw a TBD on that.
All right. A thing I want to mention, assuming Nick got that done.
We just need to add. It's done, but it's not on the website yet.
There will be very shortly a form survey thingy on the resources tab on our website. All it is asking, Nick, if you didn't make it anonymous, might as well do that. It's just asking if you're in 150, 250, 300, or if you're past that, just so we can get a better idea of when we talk about arrays, if people actually know what an array is, kind of stuff. It makes it easier to know how in-depth we can go. So it's purely informative. It does not matter what you put. We just want to know so that if we start talking about something super complex, we'll be able to know that there are people who might not know what a linked list is yet. So do that whenever we put it on the website. Presumably very, very soon. But if there are no other questions, we're done. You can go eat or do homework or whatever you do in your evenings.
What?
What language is TBD on?